Welcome back everybody to Section 2. We're going to be covering the history of geology. First, Aristotle. So Aristotle had this series of observations about things that he saw in the natural world. For example, asking questions like, with the amount of salt that flows from the Nile River into the ocean, how long would it take to get all the salt into all the oceans in the entire planet? And as part of his understanding, he came to realize very quickly that Earth changes so slowly that a lot of these changes can't be observed on the scale of a single human lifetime. We'll cover this more later, but plate tectonics is a great example of this. You could stand on a plate your entire life and have no idea that it was moving. And in fact, that's what happened. Skipping ahead a little bit, a few hundred years here, we go to the 10th century, Middle Ages in China. Was an individual there, forgive my pronunciation, Shen Kuo. Actually kind of a prolific guy, lots of research, advanced a lot of different fields. He discovered this fossilized old bamboo in a region of China that's actually very dry and cannot grow bamboo. And he proposed an explanation for this. He said, well, the climate here must have been different a long time ago whenever this bamboo was buried. And in fact, well, not only is he exactly right, but he was the first one to sort of write down this observation about a gradual change in climate. Very first one to do this. Moving ahead, once again, we go to Nicholas Steno. This is in the Netherlands, 17th century. Somebody who was a scientist, I believe he was also a bishop, somebody who really questioned everything that they knew at the time about the natural world. And he put forth this idea that outside of the Earth is composed of these horizontal layers of rock, these rock bodies that are made of the same stuff throughout, called them strata. So we'll talk a little bit more about Steno, about his ideas, what they mean later on, but for now I want to talk about this fellow here. This is Emmanuel Khan, forgive the pronunciation, as always. German guy around in the 18th century, and he was the first one to really spend time writing about, thinking about this question of how old is the Earth. As far as geology as a science goes, this could sort of be considered the original question, the original big question that in fact was so difficult to answer and interesting to answer and fundamental to everybody's understanding of life on the planet that it sort of birthed geology as its own field, and this was developed further. We'll move ahead to the 18th century in Scotland. This is James Hutton we see here. He proposed this idea of Uniformitarianism. It is one of the foundational principles of geology, one of the rules that you work with in doing earth science, and it states the following. Processes of geology which occur right now on the planet also occurred in the long past, the distant past, the geologic past, deep time and all that. You might summarize it as the present is the key to the past. Now, moving ahead a little bit, but same part of the world, we have Will Smith. That's right. Well, no, actually it is William Smith. That's our guy. So he found that fossils, these remains of organisms long past in the form of rocks, were a very, very good way to be able to tell rocks apart from each other that look really, really similar. So you have one hunk of limestone over here, one hunk of limestone over there. How do you tell the difference? Practically, cheaply. Well, you look at the fossils in them. And he actually used this knowledge, along with his knowledge of the outdoors, to produce a large-scale geologic map of the whole of England. This is the first quality geologic map that was ever produced. In about the same time period, over in Scotland, there was a scientist named Kelvin, that's right, the same Kelvin, the temperature one, who tried to figure out the age of the Earth the way that a physicist might. And I will always remember this as the loaf of bread theory. So based on what they knew about the temperature of the Earth now, and based on what they knew about the temperature of the sun, there's this sort of idea, right? You know how hot the oven is, and you know how hot the loaf of bread is that was taken out of the oven. And you can insert some of what you know about cooling rates and start to figure out about how long it has been since the loaf of bread was pulled out of the oven. And the figure that he got here is somewhere between 20 million and 400 million years old. This is small. This is way smaller than the actual age of the Earth at 4.56 billion years. And this is actually a very common theme. A lot of the earlier folks, even the ones that were very bright scientists who tried to figure out the age of the Earth, they came up with these measurements that are just way too small. Turns out that the Earth is far older than anybody then was able to really even predict or to calculate out. No matter how they tried to solve this problem, the figures they got were just much too small. Moving ahead still, we're in sort of the early 20th century now. We have in Germany a man named Alfred Wegener, and he proposed this idea of continental drift. And his idea is very, very good quality idea. It is right as far as we know. That's why we call it a theory here in the PowerPoint. Proposed the theory of continental drift. True as far as anybody is able to tell. It suggests that continents themselves are moving. So one went that way, and then one went that way, and one went that way. And he used all these sorts of different modes of evidence to put this together. And despite the fact that a lot of his evidence is very convincing, nobody believed him. But we'll put more on that in a bit. Stick around for the next section. We're covering Earth's place in the solar system. It's cool stuff. Don't miss it.